Hi, I'm Sean Gannon, and this is Minute Math. And today we're learning about equations with variables on both sides. In this video, we're going to cover balancing a linear equation. Then we're going to compare two salary plans. We are representing cost constraints. We have non-negative solutions in context. And lastly, we have a problem on total cost modeling. And so, when you're ready, let's get started. Solve for x in our equation 5x plus 4 equals 3x plus 10. We do not have like terms on the same side of our equation, so we need to combine them by bringing them over to one side and to the other. Let's bring our variables to the left and our constants to the right. I'm first going to subtract a 3x to both sides of our equation. Simplify this out. 3x cancels here, and 5x minus 3x is a 2x. I'm going to bring down the plus 4 and bring down this 10. Now, let's bring the constant to the right. I'm going to subtract a 4, opposite of addition, subtraction. Subtract a 4 to both sides of the equation. 4's cancel here on the left. And I have 2x by itself is equal to 10 minus 4, which is a 6. Lastly, multiplication between the 2 and the x. Opposite of that is division. Divide 2 to both sides of the equation. 2's cancel on the left, giving me x by itself is equal to 6 divided by 2, which is a 3. And so we solved our equation for x, and we got x equals 3. Company X pays $300 weekly plus $15 per sale. Company Y pays $350 weekly plus $10 per sale. For what number of sales will earnings be equal? Okay, let's let S be our number of sales, our variable S. And I'm going to write it like this, okay? A little cursive E, S. Not the best at cursive, but that's what we have here. That's going to be our number of sales. And I do that because my S kind of looks like a 5. All right, so let's create an equation now using S for the number of sales for each company. X on the left, Y on the right of an equal sign, and see where they're equal. So our company pays $300 weekly. So $300 is a fixed amount they're paying us, plus $15 per sale. So 15 times the number of sales we have, our S. And that's equal to, now, company Y, we're trying to find when it's equal to. So we said the second equation, company Y, is $350 weekly plus $10 per sale. So 10 times S. Now we have an equation to solve. If we solve for S here, we can see the number of sales where both, companies, their payment is equal. All right. So to do that, we're going to combine our like terms and bring them together. I want to bring the 300 over to the right first. I'm going to subtract a 300 right here. And that leaves me with, 300s cancel on the left. I have 15S right here. Is equal to 350 minus 300, which is 50, plus a 10s. Now, bring a 10s over to the left. I'm going to subtract a 10s to both sides of the equation, like that. And 15s minus 10s is a 5s, is equal to a 50. Remember, these cancel on the right. Now, lastly, I need to get s by itself. We have multiplication here. Opposite of that is division. Divide both sides by 5. 5's cancel on the left, leave me s by itself is equal to 50 over 5, which is 10. So the number of sales that we need to have where the earnings would be equal would be 10 sales, and both companies would pay the same amount. Store A charges $1 per apple plus $2 delivery. Store B charges $1.50 per apple, and there's no delivery fee there. When are the total costs equal? All right. Let's let little a represent the number of apples. And we want to determine how many apples we have to purchase at each store where the costs are exactly the same. So let's get an equation for the cost for store A. They charge $1 per apple, so 1 times the number of apples we purchase, A, and then plus a $2 delivery fee, plus 2. That's a constant. Now we want to set that equal to the store cost for B, right? The cost for store B. They tell us here that it's $1.50 per apple, $1.50 multiplied by A, the number of apples we have, but there's no delivery fee, so like a plus a 0, right? So now we have an equation where they're equal. We're setting each store costs to each other equal, and we determine what A is that makes them equal, all right? So 1A is just A by itself, right? Plus 2 is equal to 150 A plus 0, but we don't need the plus 0 there. All right, so now let's get our like terms together. And this gets a little tricky. We have 150 and we have A, 1A here. So I'm going to subtract a 1A. You can have it there if you want, if it makes it easier. Minus 1A to both sides of the equation. Get it to the right. 2 is by itself. These cancel. And 150 divided or minus 1 is 50 cents, 0.50 A. All right. Now, if you're like me here, I'm going to convert that to a fraction to help visualize it. 50 cents or 50 cents 0.5 is like a 1/2. It makes it a little easier to see. Then, if I multiply that by 2 to both sides of our equation, 1/2s cancel on the right, leaving me with A by itself, and 2 times 2 is a 4. We can rewrite this to have A come first. A equals 4. And so the number of apples that we need to purchase for the store cost for both of them is equal. The total cost would be 4 apples. A truck weighs 100 pounds and each box adds 50 pounds. The truck has a 500-pound limit. What is the maximum number of boxes we can have on the truck? Now granted, this is kind of a small truck, but only 100 pounds is what it is. Let B here, our variable, be the number of boxes. Okay, so B is the number of boxes. Let's get an equation here to get to our maximum level. So our truck weighs 100 pounds. That's a constant. We already have that. Plus, each box weighs 50 pounds. So 50 pounds times the number of boxes we have in the truck. Now they tell us here that this truck has a 500-pound limit. So the number of boxes that we have has to be less than or equal to that 500-pound limit. They tell us that. Now, they want to say, what is the maximum number of boxes that we can have in the truck? So essentially, we can write this as just equal to that maximum amount. We want to see if we can equal that maximum amount. Now, granted, we cannot have partial amounts of boxes. So if this becomes like a fraction or a decimal, we'll have to round down to whatever that whole number is here, the maximum that the truck can have. Now, what if we had negative boxes? Is that even possible? Well, no, right? We can't subtract boxes that weight from the truck with the boxes. So all of our boxes can be 0 all the way to whatever our maximum amount that we have as whole numbers. Okay, let's solve for B here. I'm first going to subtract 100 to both sides of the equation. This cancels the 100 on the left, leaving me with 50. B on the left is equal to 500 minus 100, which is a 400. Now I have multiplication, 50 times B. Opposite of that's division. Divide 50 to both sides of the equation. 50's cancel on the left. B is by itself is equal to 400 divided by 50, which is an 8. And we got a whole number, perfect, right there. So that equaled, if B goes in here, or 8 goes in for B here, we get 500 pounds maximum. So the total number of boxes, the maximum number of boxes we can have on the truck are 8 boxes. Store A rents bikes for $10 an hour with a $20 fee. Store B rents for $15 an hour, but there's no fee that's mentioned. At what hour count are the costs the same? Okay, so let H here, the variable, represent the number of hours. The number of hours we're renting the bike. Let's start with store A and see if we can find an equation in a sense that models the cost of renting store A. So it's $10 per hour, so that's a variable here. So $10 times H, the number of hours, with a fee, a constant fee, we're adding that to it, of just a 20. And it's just 20 straight up. Now we're going to set it equal to store B. Now store B's cost is just $15 per hour, H being the number of hours that we're renting, and there's no extra fee that we're adding. So now we have an equation where the costs at each store are equal, and we solve for H, and we see which number of hours makes that equal. All right, well, we have 10H and 15H here. Let's bring that over to the right, have our like terms together. So I'm going to subtract the 10h to both sides of the equation. 10h's cancel on the left, leaving me with a 20 by itself is equal to 15h minus 10h is a 5h. Now I have 5 times h here, so opposite of that's division. Divide both sides by 5. 5's cancel on the right. H is by itself, and 20 divided by 5 is a 4. So our value for h here is 4 hours, and that is how long we would have to rent the bike at both stores for the total cost to be the same when it's 4 hours. Let's recap what we have learned in this video. We first were balancing a linear equation. Then we're comparing two salary plans. Then we represented cost constraints. We had a non-negative solutions in context. And lastly, we had a total cost modeling problem. I now leave you with a bonus problem. Worker A earns $50 per day plus $5 per task. Worker B earns $55 per day plus $4 per task. When are their total earnings equal? Well, really, how many tasks do they have to complete that their earnings are equal? Best of luck. I hope you learned something here on equations with variables on both sides. And as always, thanks for watching.